Hello students, today you're going to take notes on Cornell notes on Epicenter. These are the ones where you write your question on the left and then a summary and advanced question at the end. There will be one thing you have to draw, but it's going to go here, so that's why the picture is already there. But we'll get to that in a minute. If the video is going too fast, remember just pause it or rewind it. Alright, let's get started. For number one, write seismograph. A seismograph is a machine that records the strength of seismic waves. On the left here, you can write, what is a seismograph? Again, that's the question I'm going to provide. The rest of them make your own. And if I haven't graded your notebook, make sure that you have it. And if I did grade your notebook, have it as well. I'll grade your notebook next time. So here's a picture of a seismograph, and it has a needle and it moves back and forth. Although now most of our seismographs are digital, this is one of the original ones. And when it would feel vibrations, it would record the movement of the earth. All right, let's move on. Number two. For number two, write the focus and epicenter. So the focus, and this is where I was telling you you're going to have to draw a picture, is the place in the tectonic plate where the earthquake began. So in this tiny little picture, the focus is right here in the middle. And the epicenter is the land right above it, so that would be up here. So go ahead and draw it underneath that definition. I'll leave this picture for a second, pause it if you need to, and you can see it's clear here. So the focus is where in the fault the earthquake began, and the epicenter is where we feed it on top of the land. The epicenter would be right here on the top of the focus. Okay, go ahead and draw that picture underneath number two. I'll put number two back. And go ahead and come up with a question for number two. Okay, you ready? Let's move on to number three. For number three, write, earthquakes are measured with a moment magnitude scale. To be honest, there's multiple scales. There used to be one called Richter, and there's another one too, but this is the one that's most commonly used today. And I feel it's the easiest one too. So when you hear about earthquakes, mostly they're using the moment magnitude scale, and it works with numbers or forces of 10. So if you have a 4.0 and then you compare it to a 5.0, it's 10 times stronger, or vice versa. A 3.0 is 10 times weaker than a 4.0. And like I said, from 8.0 and above, those are really rare. But 2.0, 3.0, those are much more common. And the magnitude scale measures them in forces of 10. The other scales use different numbers. All right, go ahead and write that down. And here is an example I'm bringing up right now. So a 4.0 is about 10 times stronger than the 3.0. So you can see that if you multiply times 10 times 10 times 10, you can see that there's a huge increase in energy. All right, and the last one for today is seismologists have noticed that weak earthquakes, such as 1.0s and 2.0s, are much more common. And then strong ones are much rarer. 8.0s happen like on Earth about once a year. And sometimes we go a whole year without one. But along the Ring of Fire, we always have earthquakes. They're usually just weak. Okay, go ahead and write your 4-sentence summary, and that's the end of this video. And don't forget an advanced question. Have a good day.